Okay, welcome everyone. This is 3.2 on polynomial functions and their graphs. We're essentially going to talk about polynomial functions and their graphs, but the main point about this is how to graph a polynomial function. Okay, so the end product is we are going to be graphing polynomial functions. Okay, so just a little background on it. This is a polynomial function. I know it looks kind of difficult, but I assure you that it's going to be quite simple, okay, in this lesson. Okay, so that's a polynomial function. And then what we need to know is some background information, some math terms that we use, that we're going to use while graphing, okay? So the leading term is 3x to the fifth, okay? That is the first term of this in standard form. Okay, standard form, remember, is the biggest or the greatest exponential value, and then it goes in decreasing order. So it goes from x to the fifth, right? So 5 is your degree, and then 6x to the fourth, and then negative 2x to the third, and then plus x squared plus 7x, and then minus 6, right? So it goes from starting from the greatest, and it goes in decreasing order. Okay, so your leading term after you put it into standard form will be the leading term, 3x to the fifth. So the leading coefficient is 3 because that is the coefficient of your leading term. Okay, and that's a positive 3. Positive and negative is what we are going to use while we are graphing. Okay, and then the degree of this polynomial is 5 because that is the biggest exponent here. If you have multiple exponents, just FYI, you just add the powers. Okay, so if it's like, for example, if it's 3x to the fifth, y to the fourth, this degree would be 9. Okay, because 5 plus 4 is 9. Okay, so you just add the powers and then you'll get that. Okay. So the basic functions that we are going to learn about today, and you guys should know by now, is these three right here. Okay, y equals x, y equals x squared, and y equals x cubed. Okay, we all know how the graphs look like, and there's those graphs, right? The red line is y equals x. This parabola is y equals x squared, and then this cubic function is y equals x cubed. All right? So, for example, at 1 would be at 1, 2, if you go up here, this would be 8. A negative 1 would be a negative 1 here, okay? And then a negative 2 here on my x would lead me to negative 8, okay? If you plug in negative 2 into here, you get a negative 8. If you plug in 2 into here, you would get an 8. That's why this is so sharp. All right? So the first thing we got to know about graphing, remember our end product is about graphing. It's about graphing these guys. All right? So the first thing we're going to talk about is end behavior. And that in a nutshell is what is happening at the ends of the graph. Okay, at the end of the graph, what is happening to my function? Okay, so the end of the graph is along my x-axis. Okay, so as x approaches negative infinity, so I'm all the way to my left-hand side of my equation, right, to my graph. What's going on with my graph? What's y going to be approaching? Okay, and then as x approaches positive infinity, all the way over here on my graph, what is my function doing? What is y approaching? So for example, if we take x squared, for example, right? If I'm all the way over here towards negative infinity, this end behavior is going to be shooting up all the way and off of the screen, right? So once it does that, it's approaching positive infinity because then it's going up and up and up and up and up. So it's going to be approaching positive infinity. As x approaches positive infinity, so I'm all the way over here towards the x-axis, this graph, this parabola moves up and up and up and up and up again. So it moves towards positive infinity. So for y equals x squared, my n behavior would be as x approaches positive negative infinity, y approaches positive infinity, and as x approaches positive infinity, y would also approach positive infinity. For, let's say, for example, this one here, as I'm approaching negative infinity, or I'm all the way to the left-hand side, or the negative side of my x-axis, right? All the negative values, -2, -3, -4, -5, -1,000,000, -2 million, -3 million, -4 million. This graph will go all the way down and down and down, if you follow my finger off the screen, all the way down towards negative infinity, right? So for this value, for this function here, as x approaches negative infinity, y would approach negative infinity, okay? As x approaches positive infinity, or I'm all the way over here and towards the end of my screen, this graph will go up and 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 up, right? So it approaches positive infinity, okay? Normally, or most likely, it's going to go towards positive or negative infinity, depending on the function. Sometimes it's going to go towards a number, okay? But in this lesson itself, it's always going to go either positive or negative infinity, all right? So let's dive in a little deeper on end behavior and talk about what happened, okay? Notice that in this case, in our first example here, right, 3x to the 5th, we're going to be graphing these type of functions, okay? And I have no idea what happens on 3x to the 5th. I don't know that, that graph off the top of my head. So we're going to break it down. When we're graphing, we're going to break it down by end behavior. Okay, so if the polynomial's degree is even, think x squared. We know how x squared looks like, right? We know what x squared looks like. It looks like a parabola. Okay? So think x squared when the degree is even. So if my leading coefficient, or if that a value is positive, remember that it goes up and up, right? It's a smiley face. Okay, so my end behavior is actually here and here. All right. If my leading coefficient is negative, it looks like a frown face or a sad face, and my end behavior is here and here. So as x approaches negative infinity, it's going to approach negative infinity. As x approaches positive infinity, x is going to approach, or y is going to approach negative infinity. Okay? And vice versa here. Negative infinity leads me to positive infinity, and positive infinity leads me to positive infinity. Okay? If the polynomial's degree is odd, you're going to think y equals x cubed. Okay, the cubic function of it, which is this. If my leading coefficient is positive, that's my end behavior, here and here. Okay? If my leading coefficient is negative, it's going to be the opposite. All right? So we can make a little chart. Okay? So if I break up this chart like this, your end behavior is broken up into two things. If the degree is positive, or if your degree is negative, okay? And if your leading coefficient is positive, and if your leading coefficient is negative, all right? So if your degree is even, like this, you're gonna think x squared, and if your leading coefficient is positive, your end behavior is like this, right? So it looks like this, and it looks like that. This means that as x approaches negative infinity, y is going to approach positive infinity. And as x approaches positive infinity, then y is going to approach positive infinity as well. They go up and up, so they're both going towards positive infinity. If your degree is, oh no, I'm sorry, I didn't say, I put plus and minus here, huh? I should have put even. And if your degree is odd. Okay? So if your degree is even and your leading coefficient is positive, then that means that it looks like this. If your leading coefficient is negative and your degree is still even, then it looks like this and it looks like this. That end behavior is as x approaches negative infinity, or the left-hand side of the graph, y is going to approach negative infinity. And then as x approaches positive infinity, or the right-hand side of your graph, y is going to approach negative infinity. Okay? Here, if your degree is odd, you're going to think x cubed, because that degree is odd. And then your end behavior looks like that. Right? Let's do that. Okay? So here, if your leading coefficient is positive, then your end behavior looks like that. Right? So that means that as x approaches negative infinity, or this side, the left-hand side of the graph, your y is going to approach negative infinity as well, because it goes down and down and down and down. As x approaches positive infinity, y is also going to approach positive infinity, because it goes up and up and up and up. If your degree is odd, the last one, if your leading coefficient is negative, then it looks like this, right? That means that my end behavior looks like that. And what that is as x approaches negative infinity and as x approaches positive infinity, what's happening to my y's? As x approaches negative infinity, it's going up and up and up and up. So it's going towards positive infinity. As x approaches positive infinity, or the right-hand side of the graph, down and down and down and down, it's going towards negative infinity. Okay? So if you just know the arrows, you should be good. All right? That is end behavior. This is end behavior in a nutshell. Okay? So that's that. What else we got to talk about really quick is the multiplicity. Okay, the multiplicity is we're talking about the zeros of the function and how many zeros or roots do we have. If it's an even number, then it bounces off of that zero. So it's heading down and it bounces, right? So at this point here at 3, it's gonna bounce off and then go in the same direction, right? It's bouncing. off of that 0. Okay. Here, if it's odd, if the multiplicity is odd, then it's going to go through it. I know I just introduced this. I'm going to kind of solidify this idea with my graph. Okay, when we're doing the graphing example here down here. Okay, so when it's an even multiplicity, it bounces. When it's an odd multiplicity, it's gonna go through it. Okay, so the multiplicity here is actually this number here. Okay, and the multiplicity here is this number here. Because if it's x minus 3 quantity squared, that means I have, if I expand this out, I have 2 x minus 3's, right? And then if I solve it for 0, x minus 3 equals 0, then x equals 3. That's why that's at 3. Okay, because this 3 is this 3. Okay, that's my x-intercept, right? If I make y equal to 0. But I have 2 of these 3's. That's why it bounces. Okay, and I have 3 of these 3's, same thing, same math. This 3 would just be this 3, right? And then since I have 3 of them, and it's an odd number, it's going to go through it. Okay? And again, I'm going to do a graphing example here with the multiplicity, so don't worry if you do not understand that. Okay? So how do we approach graphing? Okay? Here are the steps to graphing it, and stop the video if you need to just write out the steps. Okay, the first step is to find all the zeros. Okay, if you're gonna factor if needed, and you're gonna find the y-intercept. Okay, so you're essentially, when you're graphing, you're gonna find the x-intercepts and the y-intercept. Okay, all the x and y-intercepts of the graph. Okay, we find the x-intercepts by finding the zeros. You find the y-intercept by making x equal to 0. You find the x-intercepts by making y is equal to 0, right? So here, it's already factored for you, so you don't need part A of your directions. Okay, sometimes it'll be unfactored, and you just have to take some time to factor it out. And we'll do some practice in class. Don't worry about it. I'm gonna find my x-intercepts first by making p of x or y equal to 0. So that's 0 equals negative x plus 1 quantity squared times x minus 1 cubed times x minus 2, right? So I know x plus 1 has to be 0. I know x minus 1 has to be 0, or x minus 2 is equal to 0, right? You're going to set each factor equal to 0. Then just solve for x. Okay, x is equal to negative 1 here. X is equal to positive 1 here. And then x is equal to positive 2 here, right? If you just solve for 0. If you just solve for x, I mean. And then the second step is to find the multiplicities of the 0. Or before you do the y-intercept, okay? Multiplicity here is 2 because there's 2 of them. And I just put M2. Multiplicity here is 3 because there's 3 of them. And the multiplicity here is 1 because there's just 1 of them. Okay? Backtracking to my y-intercept. My y-intercept, I'm going to make x equal to 0. So p of x equals, I'm going to just plug in 0 into my function. Not x, but 0 minus 1 quantity cubed times 0 minus 2, right? I just plugged in 0 for my x values here. So I have negative out here, 1 squared, negative 1 cubed times negative 2. that is -1 times -1 times -2. 1 squared is 1. The negative just drops down. 1 squared is 1. -1 cubed is -1. -2 just drops down. So -1 times -1 is a +1 times -2. That's a -2, right? P of x is -2. So I have a y-intercept of 0, -2. Okay? And all of these x-intercepts, I have -1, 0, I have 1, 0, and I have 2, 0. All right, so I got 1, 2, 3, 4. 4 points of my graph, and I'm well on my way to graphing this. All right, my next step is end behavior. Okay, remember this, we got to find a degree if it's even or odd, and we got to find if the leading coefficient is positive or negative, right? So if I look at this, here, the highest degree here is x squared if I just, because I have x and I have squared here. So my highest degree is x squared. Here I have an x and I have a 3. So here my highest degree is x cubed. Okay. Here I just have one x, so I have one x. So I have a power of 1, right? 3 plus 2 plus 1, that's 6, right? So this function has a degree of 6, which is an even number. Okay, so it's an even degree. Even degree, so I'm here. It's what's my leading coefficient though? Since this guy here has a negative value right there, right? It's negative. If it wasn't there, it would be positive. Okay, so my leading coefficient is negative. I have an even degree, so my end behavior is this guy. So it's down and down. Okay, so let's write that out, down and down. And then the fourth point is to connect all of this information. Okay, so I have graph paper here. Okay, my first step, let me see, is that I have my x-intercepts at -1, 1, and 2. So -1, 0, 1, 0, and 2, 0. Those are my zeros of the function, right? At -1, 1, and 2. I know my end behavior. Oh, and I have another point. My y-intercept is 0, -2. So I know that the graph somehow, some way goes through this as well. Okay. My end behavior is down and down. So I'm just going to draw this down here. Okay. So I know my graph is going to end this way. Yeah. Okay. Check, check. Here at -1, remember that my multiplicity is 2, which is even, which is going to bounce. So right here at -1 has a multiplicity of 2. I'm going to draw this guy because I know it's going to bounce, right? So it's going to come up. It's going to come up from here, go to -1, and bounce off of it. Okay? And then at 1, it's multiplicity of 3. So it's going to go through. So it's going to go through it, like go through the point. So actually, I'm just going to put a T there for through and a B here for bounce. Okay. I know if you don't know this yet, that's fine. I kind of skipped a step. So bounce B is for bounce, T is for through. At 2, my multiplicity is 1, which is an odd number, so it's going to go through. Okay? So now, that's all we basically need. All right, we're going to add some more information here later, but for now, this is going to be my graph, and this is what you need. So I know my graph starts from down here, and it goes up, and I know eventually it's going to go up to -1 and hit that point, right? Because that's one of my zeros. It's going to bounce off of it, and my next point is the y-intercept. So I'm going to come through. I know it's going to hit that point there, right? But I know it's going to go through here at 1 because that's one of my zeros, so my graph has to hit it. And at this point, it's going to go through it because its multiplicity is odd. But I know I'm going to have to come back down to go through this point at 2. So I'm going to just draw something that drops back down. And then here, you're just going to go to the end behavior. Okay? So that's what that graph looks like. All right? That's a quick synopsis of what we're going to be doing. Here is the steps again to graphing. And I'm going to expand on this in class later. Okay? Bye, guys.